Welcome back, learners. So now, as you have said, we're jumping to our application questions that are still based on a series circuit and also a parallel circuit. So our first question says, from the diagram that we have alongside, what is the voltage across each of the lamps if the battery can supply a voltage of 6 volts, provided that the light bulbs are identical? So these two lamps, these two light bulbs that we have, they are identical, meaning that even their resistance is going to be the same. Now, with all of that information given, we are also looking at this diagram and we are seeing that when your current is flowing through the wires, when it gets to this point or this point, it has to split. Some of the current has to pass through the first resistor and some has to pass through the second resistor. And because of that, it tells us that this circuit is connected in parallel. Now remember, if it's connected in parallel, there are certain clues that we know about this particular circuit. That number one, the current divides as we can see, and number two, the voltage remains the same. So the voltage provided by the battery is going to be the same at each and every resistor that we are going to be measuring it across. So therefore, from the diagram, what is the voltage across each of the lamps if the battery can supply a voltage of 6 volts, provided that the light bulbs are identical? Because this is a parallel connection and the battery supplies a total of 6 volts, that also means across this first light bulb, there's going to be a potential or a voltage of 6V, and also across this light bulb, there's also going to be a voltage of 6V. Remember, V total is going to be equals to V1, also equals to V2 in a parallel circuit. The voltage of the entire circuit is going to be equals to the V measured across the first resistor, hence the V1, and then also going to be equals to the voltage measured across the second resistor, which is now our V2. So therefore, our answer here is C. Moving on to the next question. It says, from the diagram again, still using the same diagram, what current is drawn, or from the diagram given, what current is drawn from the battery if the current through the first lamp is 1 amp and the current through the second lamp is 3 amps. So if this is our first lamp, lamp number 1 and lamp number 2, and we are told that across or passing through this lamp we have 1 amp and the other one we have 3 amps. Remember, in parallel the current divides. It divides proportionally, and still the sum of the currents in each of those resistors that we have, in this particular case the 2 resistors that we have, is going to be equal to the sum of the total current. So if across this resistor we have 1 and across this one we have 3, when we add, when this current has passed through this resistor, these 2 resistors, and then getting to this point, they will still combine and be equals to the total current that we had initially. So therefore, 3 plus the 1 gives us the 4. So therefore, the total current is going to be D. Our answer is going to be D, which is the 4 amps. Next question. Now it's a true or false question, whereby we need to write either T or F, T if the statement is true or F if the statement is false. Question 1. Parallel circuits are characterized by the fact that there are multiple pathways by which charge can travel from the positive terminal to the negative terminal. Now remember, a parallel circuit is one whereby there's more than one way, or there's more than one pathway that a current can take flowing from one point to the other. So because we are saying that a parallel circuit is characterized by this fact that there are multiple pathways by which a charge can travel, moving from a positive terminal to a negative terminal. So therefore, this statement is true because there are multiple pathways by which the charge can travel. If it's just one single pathway that a charge can travel, that means that circuit is connected in series. Next question. During any single loop of charge around a parallel circuit, the charge will pass through each resistor in the circuit. So, as your charge is moving from one point to the other, during any single loop of charge around a parallel circuit, the charge will pass through each resistor in a circuit. So as the charge is moving from the terminals, from the battery, throughout the entire circuit, at a particular point, the charge has to divide so that it can travel through each of the resistors, provided that the entire circuit is closed. However, should the circuit be open, in that branch where the circuit is open, there won't be any flow of charge. But if the circuit is closed, therefore, the charge is going to pass through each resistor in a circuit. So therefore, this makes the statement to be true. Next question. Again, still true or false, T if the statement is true and F if it's false. The overall resistance of a circuit increases, resistance increases as more resistors are placed in parallel in the circuit. So when we are adding more resistors in a parallel circuit, what are we doing to the entire circuit to the entire resistance of the circuit? As we are adding more resistors in parallel, the total resistance of the entire circuit is going to decrease. And by that, the current is going to increase, provided that the voltage remains the same. So therefore, rereading this question, the overall resistance of a circuit increases as more resistors are placed in parallel in the circuit. So this is false because as we are adding more resistors in parallel, the resistance must decrease if we are adding them in parallel. So therefore, this statement is false. So F for false. Moving right along, the total current in a circuit increases as more and more resistors are placed in parallel in the circuit. So now we are looking at the current. When we are adding more resistors in parallel, as more resistors are added in parallel, the total resistance decreases, and because of that, the current is going to increase. So the total current in a circuit increases as more and more resistors are placed in parallel in the circuit. So this statement is true because of the relationship that they have between the resistance and the current, that they are inversely proportional to each other. Now question 4. We are supposed to draw a circuit diagram that is showing a closed circuit with two cells. The two cells are in series and the two light bulbs that are in parallel. Remember, in series, it's one after the other, and the light bulbs being our resistors, they are going to show the multiple ways in which the current can take when it is moving from one point to the other. So remember, two cells, a negative terminal, a positive terminal. This now gives us one cell. To have another one, we need to have another positive and another negative. Now, the cells are accounted for and they are in series because they are one after the other. What we need now are our two light bulbs that are connected in parallel. So, we are going to have our wires and a symbol for the light bulb. And then remember, there needs to be more than one pathway for the current to take, so therefore, and we can put our switch there to show that it's a closed circuit. There's no opening anywhere on this circuit, so when your current is flowing from the terminals, once it gets to this point, it has to split. Some has to pass through this resistor, this light bulb, and the other has to pass through the second light bulb. However, after having passed through those light bulbs, at this point, the currents the one that passed through this resistor and the one that passed through this resistor, they will add up together here and be equal to the total current of the entire circuit. Remember, we are using our light bulbs as our resistors. And question 5, we're going to draw a circuit diagram. And on this circuit diagram, we're going to be showing a closed circuit, so there must be a closed switch, that has an ammeter and also a resistor in series. Now, we also need to have 3 cells that are connected in parallel with a voltmeter connected to measure the potential difference across the 3 cells. So there's a lot of information that we have here that we need to showcase in a circuit diagram. So first of all, starting with the 3 cells connected in parallel, we are going to have 1, 2, and 3. Now, all of these, they are going to be connected in parallel. So connecting our 2 cells in parallel, remember, all of these cells, they're actually making up one bit, or they're making up one cell of the entire circuit, which is why we say the total V across each cell is going to be the same as that of the entire cells combined in a circuit. So the 3 cells connected in parallel are accounted for. There must be now a voltmeter. So there must be a voltmeter again, so we're going to connect, it must be connected to measure the potential difference across the 3 cells. So we're going to connect our potential difference here, denoted by V, to show not our potential difference, our voltmeter, that is denoted by V. Across 2 points to measure the potential difference across the 3 cells. Now the voltmeter is connected, it's accounted for. What else now do we need? We also need now an ammeter. So an ammeter has a symbol A, capital letter A. It's a device used to measure the electric current of the circuit. We also need to have a resistor that are connected in series. Remember, if they are connected in series, they need to be one after the other. And then anything else. So we have a circuit diagram. Close the circuit. You're going to finish up with that. With an ammeter, ammeter is drawn. A resistor is drawn. And these two are connected in series. And we have our 3 cells that are connected in parallel, with a voltmeter connected to measure the potential difference across the 3 cells. So we have our potential difference there. So the last thing now to have is our switch, our closed switch that you're going to be drawing there. So we have drawn everything. Remember, the voltmeter that we have there, it is going to always be measured, or going to always be connected in parallel because of its high resistance. So remember, when we are adding a resistor in parallel, we are actually decreasing the resistance of the circuit. So because a voltmeter has a high resistance, it always needs to be connected in parallel. Whereas a series has a low resistance, it always needs to be connected in, an ammeter has a low resistance, it always needs to be connected in series. So in this case, we are told that our ammeter and our resistor are connected in series, one after the other, as we can see. Remember, an ammeter has a symbol A and a voltmeter has a symbol V. They are measuring 2 different things. The voltmeter measures the potential difference across 2 points, as we can see, across this point and that point, to measure the potential difference across the 3 cells. And then the ammeter is a device that is used to measure the electric current passing through the entire cell. Remember, the total current will be passing through this ammeter, and also still pass through this particular resistor that we have here, because our switch is closed. Should our switch be open, there won't be any current flow taking place in this particular circuit. So with all of that said, we're just going to quickly go for a short break, and I will see you just after this.